This is part 3 of a 3-part video describing the circuit board. The first video showed this board actually in the cabinet wired up to the system. The second one, I described the output section that actually drives the relays. This portion, I'm going to describe the input section that receives inputs from the switches and the digital sensors. So anyway, so these are optical isolators, and they do all of the conversion for me. But so optical isolators, I'm going to use like this. What they do is I'm using them to convert, because see all these inputs, all of them are coming in as 12-volt digital pulses, or digital logic levels, and so. But the optical isolators, I use them to convert that 12 volts down to 3.3 volt logic signals, because the propeller has to have its input at 3.3. It's because it works at a 3.3 volt I/O logic level. So these basically shift it down. These can also shift it up. In fact, this one down here actually does shift it from 3.3 up to 12 volts the other direction. So this one is actually used as an output, actually, but all these inputs are these 1, 2, 3, 4, 5, 6, 7, 8. There's 8 inputs here, and what they do, I currently have it set for level switches, high, medium, and low. See this over here, and then this would have been the submersible pump. If it's on or off, if the submersible pump is on, then this will go high. If it's off, it'll go low. If the booster pump is on, this will go high. If it's off, this will go low. These are flow sensors, and those flow sensors they give digital pulses a little from the flow sensor. This is for the submersible pump. This is for the booster pump. And if I had a propeller chip out in the well house, its output communication would come here, and this one is designed to send an output back to the propeller chip if I had one out there. I don't currently have one. In fact, most of these are going to be changing. I'm moving away from switches for the level of water in the well. I'm actually going to go to a pressure transducer, a submersible pressure transducer that'll be put in the bottom of the well, and it'll send out at that well house. I have probably a propeller chip or another type of controller interpreting the pressure to get the level of the water, and also the flow sense. I'm moving away from the little propeller type that I have in there, and I'm going to be going to ultrasonic flow sensing. So I'm moving away from these two as well. These will still be there. I'll have for the indicating whether the power's on or off. But let's talk about the optical isolators here. Let me show you a picture of the internal working of it. Okay, what I have in there is these chips are 4N35 optical isolators, and pin 3 is not used. There's no connection, and pin 6 has a connection, but it's not used. In fact, I don't have any connection. So the inputs are on 1 and 2, the outputs are 5 and 4, and but actually I have the pin 2 grounded, because what happens is, if pin 1 is positive, sufficiently positive, more positive than 2, this photo LED will light up inside the chip. I mean, you don't see it, but it's LED. In fact, see, there's really no electrical connection here. Light is the only thing that's connecting them to. That's why they call it optical isolating. And so there's like an LED in there that if this is positive, if 1 is positive relative to 2, then the LED will light up. The light will shine on the base of this internal photo transistor, the photovoltaic transistor will conduct and electric current can flow from 4 to 5. All right, see that? So anyway, the way I have it wired up on those, that 2 is grounded and 1 is the input from the 12-volt input, actually coming from the well house, and the output is taken off pin 5. 4 is grounded and the output is off pin 5, just so we got the picture. So let me go back, let me go to the board now. All right, let's move over here. Let's take a look at this now. Zoom over here, get even better, zoom in on it even more. Okay, so now, so coming from the well house, input coming through, this actually had 10K resistor, and my specs, they just suggest that 10K going to the input here on pin 1, and 2 is grounded. So now remember, these 2 drive the LED inside there. So if 1 is positive relative to 2, pin 2, then the LED will light and that transistor will conduct, and current can flow from 4 to 5. If 1 is grounded or 0 volts, then because both of these will 0, the LED will not light up, the transistor will not conduct, and 4 will not be connected, to 5. And what happens actually, because of that, there's a 3.3 volt pull-up resistor right here that will pull 5 high if this is switched off. If I have a ground coming through here, take note, it's actually reversing the voltage, isn't it? If I have a high come in here, I'll have a low here. If I have a low here, we'll have a high coming out. So anyway, so this is a 3.3 volt pull-up resistor right here on 5. So if the transistor is turned on because this is conducting, then ground will be patched, it'll override this pull-up resistor, and the input will be grounded or 0 volts. If this is 0 volts coming in, and this is not, if the LED is not turned on, this transistor will not be turned on, and the output will be pulled to 5 volts. When 3.3 volts, it'll be pulled to that. It wasn't my intention. I didn't mean to do that. Have it inverted like that. I took a drawing out of one of my books that I've used before. Apparently the drawing was labeled wrong, or I chose the wrong one. Anyway, just so I know that when I have a high coming in here, this input optical isolator is going to be outputting a low. It'll be inverting. All right. So anyway, all of the inputs are like that. Okay. All of them, and however, this one right here though is an output, and I'm usually when I drive an LED, I prefer to use a buffer. This is 7404 buffer. So let me just kind of follow with me here on this. It's kind of, I could have had 14 go right over to pin 1 and had 2 put to ground and be done with it, but no. I had a 7404 buffer in there to build a signal up to 5. Because see, the output of this will be 3.3, but the output of this 7404 will be 5 volts. It'll not only boost up the voltage, but also the power. So it's high input impedance on the 7404, so it minimizes the draw on the output currents of the propeller chip. So 14 goes high, okay, and then of course what it does, and the output would be on 2, but it inverts it. All right, so this output high here, 2 will go low, but then I have the output of that go to here, 3 is an input, then the output of, so it inverts again to go high. So I have a high here, and this is high. And if I have 2 high, well, you notice that 1 is already pulled high through a 3.3 volt. I mean, it's 5 volt, but it's a 1K resistor, 5 volt being pulled high. one is being pulled high already. And if this is high, what happens is that LED turns off because they're both high. There's no difference. It'll only turn on if there's a difference between these. So if it's high, then it will not be turned on. But if it's low, then so let's just go with it high. So if it's high, it will not be turned on. If it's not turned on, then the ground will not go through here, and it'll be pulled high from this resistor right here, 6.5K resistor, pulling it high. I know it's a fluky way of doing it. Anyway, it works. So anyway, it's just so you know that optical isolators can be used for down level shifting, either up or down, and also these are kind of beefed up. They have more output too, so they can handle more current. So anyway, that's the big picture on this. These two up here, right here, these go to the Raspberry Pis. This goes Raspberry Pi 1. This will go Raspberry Pi 2. And so this one's used to the Raspberry Pi 1 handles the control panel software, and Raspberry Pi 2, what it does, it manages the access to the internet and some other things. All right. So, and these are two mode switches down here. These are pull-up resistors, 10K pull-up resistors. And so anyway, two mode switches I threw in there, an LED over here that's powered through this. So pin 15 goes to 5, and it drives this LED. It just so I can know that it's powered on and the processor is running. So, okay, that's it for now for this. I think we're covered it pretty well here. You got the big picture on what's going on with these. So, and so the main thing is you got the idea that how this works. So normally, like on the inputs anyway, let's not focus on the output right now. The inputs, so we have 2 is grounded, basically you're looking at the input coming from the well, and we have an optical isolate, so there's no current flowing through here. So this could short out, but there's no surges can happen across this bit here. And when this is on, this LED will be, it's a photo LED, will be activated, and then 4 will be shorted to 5, right? If there's no 5-volt difference here, then this will be off, and there will be no connection here. And usually I used a 5-point. You can have pull-up resistor. You can either have pull-up resistors up or down on these. So, and I don't use the base. I just have it disconnected. It's okay to do that way. Leave it hanging. So that's it for this. Okay, so all right, so we just talked about this part of the board over here now. Okay, now the fourth video I have, I've actually the next section, I'm going to be talking about software. So I'm done basically right now talking about the hardware. So we'll continue the next videos series working with the design of the software.